Welcome to Mastercut Tool Corporation. We're very happy that we'll be able to show you around a little bit today. We've been around since 1985. Our company started in a very small garage, me by myself with one machine and one little dust collector. And from there we've grown into manufacturing facilities of around 80,000 square feet. Manufacturing has come a long way from the time that we began as a manufacturer to now. The technology has really grown. It has become much cleaner and computer driven. So manufacturing offers a lot to young people starting out in life. It can be a great career. It's something that your parents can also be involved with you to look at a career path for you. So we're very happy that you're going to be able to see the types of technologies that we use here at Mastercut, the products that we make. These products are used all over the world for almost every application you can imagine, whether it's furniture building, flying in an airplane, the car that you drive. So manufacturing is at the root of many of our economic needs in this country. We're very happy that we're a manufacturer here in the United States, right here in the Tampa Bay area, and we welcome you. Thank you.
Hello, my name is Gustavo Campos and I work as a tool engineer. I have been with Mastercut Tool for 18 years. Our dedication to satisfying our customer needs drives us to produce a wide range of products. And selecting the best tool for the job often involves a complicated geometry and a specialized design. As you can see, we have here a 4-flute ball nose designed to work with metals, a 4-flute variable helix to hard metals, a coolant through drill designed to make holes, burrs, aluminum cutters, wood routers, compressions, and plastic carving tools. This one was used to carve this shape. Our production team can tackle any request for special tools. Our tools are designed to be used in CNC machines, 3-axis routers, or hand motors, depending on the application.
Hello and welcome to the Design and Engineering Department. My name is Julius Enrica. I am a tool designer and engineer here at Mastercut. I've been with this amazing team for the past 22 years. We'll go through some of the aspects of the operations that we handle in this department. That includes 2D and 3D modeling, CNC programming, and tool design. Being that we're dealing with very tight tolerances and many geometry variants, we had to come up with a system that laid out a very clear roadmap of the tool making process. Therefore, we designed the MAP, the Mastercut Automated Production. MAP implements very strict engineering guidelines that ensure precision and consistency. Well, we're here now in the 3D simulation software, which is a really great aid for us to identify any potential problems with the design of our tool well before we get the materials ready, prepare the machine, or waste any time on setup. This helps us be more efficient, reduce waste, and more accurate with quotations. During the design process, we apply the appropriate geometry to the tool based on the customer's needs. This geometry is then entered in the simulation program here in these multiple pages, as you can see on the screen here. Then it creates a 3D model of that tool based on the geometry we just entered. And then after this, we can take it to the simulation screen for the machine part, and that will also identify any potential issues with the design or diamond wheels that we've chosen, or blank configurations, or any other variables for that matter. In this case, I have reduced the blank length so I can show you what the software demonstrates when we have a collision. In this moment, the wheel or the diamond wheel is colliding with the nose cone because I've shortened the blank length. I'm going to go in here and change the blank length now to the appropriate length, and you'll see we'll get the green lights. Once the green lights are all in there and we are free of any collisions or errors, we can now save the CNC program to be used during the machine setup. We are here now in the 2D side of the software. Using the 3D model we just created, we can generate a 2D drawing that shows geometries and tolerances for this part, which will be used during the inspection and quality checks. As you can see from the screen, this matches the 3D model exactly. Engineers here have done a great job pointing out all the different tolerances and the different operations that need to be measured and inspected during the quality control. Well, as you can see from this demonstration, technology is a beautiful thing, and we have embraced it quite well. To put it in perspective, the smallest tool we make is the size of a human hair. Therefore, the importance of having very clear guidelines to make the tools.
Hello, my name is Seth, and I work in quality control department. I've been with Mastercut for 28 years. We here at Mastercut assembled a team.
We call this system our CNC First team. For this team, CNC First stands for Customer Needs Come First. The system includes customer service, simulation, engineering, production, scheduling, and inventory. All of our systems come together to provide the quickest response time and proven solutions for our customers.
This is a new product that we just launched this year of 2020. This is what we call an NX burr. This product is mainly designed to eat through stainless steel. The flute of the NX burr are produced to shape stainless steel with very minimum effort. Let me demonstrate.
My name is Stephanie Jones. I work in quality control. I've been at Mastercut for 2 years. Our quality control and inspection team are responsible for the tools maintaining geometric consistency and adhering to the strictest tolerances. Tolerances happen to be the acceptable range of variation of the physical measurements on the tools. In 2003, Mastercut successfully achieved ISO certification. ISO standards help us maintain high quality and repeatable production. Today, Mastercut has the highest ISO certification and practices Lean Six Sigma. Although we still use micrometers, HD Eurotech cameras and laser measuring systems measure the tightest tolerances and magnify up to 400 times for visual inspection. So when we do quality control, we use these Eurotechs. Basically, they're a camera, and we can measure many things like the distance and angles, radius, lots of stuff that would be on a tool. First thing we want to measure is the cutting diameter, which is just from the top of the tool to the bottom. Next thing, the length of cut, the length that the tool is actually going to be cutting. And we can measure the helix, that's the angle of the cutting edge. And this is also good for measuring angles. This one's called the dish. And that's the gash. You can also measure that edge of the cutting rake.
For our customers, the most common dimensions are diameter, length of cut, shank diameter, and overall length. Every dimension is critical to the overall performance and longevity of the tool. Measuring the tools are essential for providing consistent, high-quality tooling.
Hi, my name is David Cox and I'm with the Quality Control Department, and I've been with Mastercut for 4 years. Once our tools are completed manufacturing, they need to be kept ready to ship to our customers. We store them in what's called a vertical lift module, or VLM for short. It's basically like a giant vending machine for tools. It's able to bring the tools right down to the operator and point to the tools that shipping needs with a red light. We also have a second set of VLMs for raw material at the beginning of the manufacturing process.
Here we see our employee has scanned a barcode and the VLM returns out a tray of tools. The tool to be picked is highlighted with red light.
Many of our customers have etching and labeling requirements as well. We use a fiber laser etching machine to etch directly onto the tool shank. It can load 5 tools at once and etch them in under a second each.
Here, our etching employee loads 5 tools and rotates the carousel. She selects the proper program and sends it to the etcher. The machine etches from back to front, 1 tool at a time. Upon completion, the tools are unloaded and placed in their packages.
For the plastic tubes we package the tools in, we're also able to label them using industrial inkjet printers or thermal labels. This enables the customers to have their own barcode on the product for their own inventory tracking methods.
Here, our employee loads 5 caps and starts the machine. The machine makes several passes over the caps, depositing ink and curing with UV light. This hardens the ink. Upon completion, the tubes are printed and ready to be shipped.
Thank you for virtually visiting us here at Mastercut Tool Corporation. We hope that your visit has shown you a number of options that you can choose in your career path. We certainly wish you the very best of luck in whatever your future may be. We do hope that also this has helped you to make manufacturing a part of that future. Thank you.